on part B. All right, we're looking at number 9 from your My Math Lab homework. Part A says express the total area of the 3 swimming areas as a function of x. And then right here it says a of x equals blank. Okay. This is exactly what we did yesterday with the partition thing. Remember that? Partition thing? It's the same thing. There's one small tweak, and that would be instead of having just a single partition here and here to block it off, they're saying this is a summer camp. You have 520 feet total of those, y'all know in the pool where they have that float to let you know shallow end from deep end. Okay, so you have 520 feet total of float line to rope off 3 adjacent rectangular areas for swimming lessons, 1 for each of the 3 levels of swimming ability. So this is a rope, this is a rope, this is a rope, and this is a rope. That's the difference. Yesterday's problem, we just had the one single side and then the one side, right? Now we have how many here? We have 4. And then a beach forms one side. So let's say this is the beach. Do we need rope here? No. What about here? Yes. You need rope out there and you need rope on these 4. Okay? Suppose that the width of each area is x feet. Answer parts A through C. Okay, A. Express the total area of the 3 swimming areas as a function of x. What shape do we have here overall? A rectangle. Hold on, I have a road here on a rectangle. We have a rectangle here. What's the formula for the area of a rectangle? L times W, right? Length times width. Don't let the image complicate your thought process. Just because there are 4 partitions does not change the area, right? It's the area of this and this and this. These little partitions that are just floating on top are not affecting the area. All you need to know is a length and a width. What do they give you? They give you 520 feet total, right? And then they tell you what? That the width is x. Okay, so this is x. So we need an expression for the length using x, right? We only have 2 things to work with. You have 520 total and you have x to work with. The width is x. So what would my expression for length be? This is just like yesterday. Close. So you have 520 total, right? Okay, and if you subtract off what's been used in the width, it's going to reduce the 520. Would you agree? Okay, and we're just multiplying by the length and the width, right? So 500. I probably should have called this the beach up here. Let me move this to here. I'm going to say that this is the beach, just so that I have more room to write. There we go. All right, that's the beach. So this is my length, but my length needs to be in terms of W of the x and the 520. So this is 520 minus. How many x's are there, y'all? 4. There's 4. Bless you. Do you understand where I got 520 minus 4x? So this one's slightly different than the one from yesterday. Yesterday we just had the single width and the single length, but this time we have how many partitions. So you have to compensate for how many have already been used. If you wrote 520 minus a single x, that would mean that the picture doesn't have this here at all. Does that make sense? It would mean that there's none of those partitions. Those partitions are there, and that is subtracting off of your total float line that you have to work with. So your length is going to be the total amount. Guys, this is the same every time, by the way. It's going to be the total amount minus however many width segments you've used. Yesterday we only used one width. Today, this one we're using 4. So now let's write the formula. A of x equals, so it's length times width. My length is 520 minus 4x, and what's my width? What did they tell you? It was x. I'm going to put it in the front because it feels weird to put it after parentheses. Now it says simplify your answer, but I did this last night just to double check because I couldn't remember how they wanted you to enter the format. It took this as the correct answer when I entered it like that. I didn't have to multiply it to get it right. But when they say simplify, they are talking about you could also enter this where you do multiply it, and it should take that as well. Now the next one is different than what happened yesterday, and that's because yesterday was a standard, single block. This time we've got some more, we have some more going on right here with the 4 partitions. Yes?
Why did you put the X in the front? Is that because it was 5?
No, I put it in the front. You could have written it like this.
I know, like the other X. Like I understand the 520 minus 4x, but what about the other X?
This one?
Yeah.
Yeah, you could have put it here.
No, why is it there?
Oh, that's length times width.
Okay,
Yeah,
okay.
sorry. I'm sorry. Length times width, and the width they tell you is x.
Yes.
Yeah.
Okay, that makes sense.
This right here is the length, and then that's the width. I thought you were saying why did I position it in the front? Yeah. No, you're saying where did it come from? Gotcha. Length times width. I think if you had entered it though, if you had positioned it in the back, it would take it as well. It's the same thing. But that bothers me to be written like that. So look at the next one. It says find the domain. Okay, so this one's slightly different, and that's because we've got 4 partitions here, right? Yesterday, we only had this single corner, and we said the domain, I think yesterday we said it was between 0 and 30. Do y'all remember that? I'm going to put recall. I don't want someone to think that that's the answer here. That was yesterday. This one is different because we don't have a single width and length. We have 4 widths and then the length. So there's a restriction on x. X cannot range from 0 to 520 because we're going to have how many x's right here? We're going to have 4 of them. So to find the domain here, this is what you need to take note on your paper. You're going to solve the length equals 0. Take your expression for the length, which is 520 minus 4x, set it equal to 0 and solve it, because you're trying to find out what is the smallest amount that x can be in this problem. And since we have 4 widths, that's why we have to set this equal to 0 and solve. So subtract 520, then divide by -4, because they're both negative, and tell me what you get. $520 divided by 4. 15, or, 130. Now look at it. Let's see if this makes sense. Yeah. Let's see if this makes sense. Remember yesterday we said the length was 0 to 30. And that's because how much did we have to work with? yesterday we only had 30 to work with, right? And we said that, now realistically, you would not make this 0, because then this would be 30, and that would mean you didn't even have a side here. We said, realistically, you would not make this 1 and this 29, because that wouldn't be functional, right? But mathematically, is it possible? Yes. So we said it ranges from 0 to 30. Here, you can't say this ranges from 0 to 520, because that would mean that this could be 0, and this would be 520, but then what about those? You see that? There's a restriction on x here, because we've got to divvy it up between 4 of them. So that's why you solve that. Now let's see if our answer makes sense. If this was 130, 130, 130, 130, right? What does that add up to? How much has already been used? 520, right? Which would mean that the length would be 0, which is the same concept that we were saying here. You can't have a 0 length on one side, so we have to stay above that number that would make this a 0 length, which is exactly why the domain is from 0 to 130. Notice that it is parentheses, because you can't use 130 because of what I just showed you in green. If you used 130, that would leave nothing for the length, and that'd be a problem. So you have to stay between 0 to 130 without actually hitting 130. So these problems are always the same. They might change the scenario: swimming pool, rose garden, corner of an office. I'm trying to think. That's all I can think of. The corner office one is the straightforward. You got a length and a width, nothing fancy. The swimming pool, the rose garden. Y'all know, y'all seen gardens where they have them in sections, right? So that's where you have to stop and say to yourself, okay, I actually have more than just a single width here. I've got several. So then when it says, what's the domain, just take your expression that you found for the length, set it equal to 0, and solve. And then put it back in the picture and see if it makes sense. Okay? And I wanted to help you with that because I know it's going to come up. We are finishing 2-1 today. Find this slide.
We did the last part. The last part 3 where it says
What does it say? I forgot to copy it.
the area of the maximum at the other side of the
What did we say? And they're showing you the graph. What does maximized area mean? Look for on the graph. The max. The maximum point. Mm-hmm.
What about the, what is that?
You're going to want to find the max in your calculator. You don't want to just try to look at the graph. You'll type that function that you came up with. You'll type this function in your y equals and then find max. You are going to have to expand your window because if you look at it, you know, it's 520 minus 4x. Remember, let me see the picture. I'm just going to copy that graph real quick. If you look at your graph on your computer, you can see kind of what window to use. Look at the graph on your computer to see your window. Like the X max looks like it's going to 230. And then the Y max looks like it's going to 52,900.
Wait, Miss Holcombe. So I did mine did a straight line.
You have to put it, I think I put it
Your no, it should still calculate it.
you have to zoom out. Like,
You're
all
zoomed
the way.
in really, really,
I
really
did
close.
zoom fit and it still didn't.
This is, if you look at your window,
How do you do that zoom window?
you can just go to your window and do the X max and the Y max are what you wanna change in the window.
To make them bigger?
Hold on, I wanna change the scale too, cause this is gonna be insane.
You just go to zoom.
Use your,
I have to do mine like
go to your graph.
I had to do
Oh,
it like
you just wouldn't keep them
Oh,
bigger?
your graph was totally different than hers. I forgot about the numbers. See, look at your Y max 10,000, your X max 100. I was using the 60,000 under social. So X max was 100. Let's go to 150. I'm sorry, and then we're gonna count 25s. Y max is 10,000. So I'm going to 15,000, and let's count 5,000. Look.
I know you know how to make your like how far out you want.
That's what I'm gonna show you. So y'all use the graph that's in your picture on your computer screen.
Oh my God, they're in the
Use that
thousands.
graph as a guide. I'm pulling Ava's up here because I saw hers. Now her numbers are different than yours because hers were 110,000, so totally different. But you're looking at your X max and you're looking at the Y max, and you need to fit yours to go just a little past those numbers. Or you could put it right at those numbers because you're just finding the top of the curve.
Has to be.
And then you want to change your scale. So, for instance, your scale, Ava, because that is just a gigantic number, I would almost count by like 10,000 or 15,000. Well, it depends. Her Y scale needs to be really, really, really high because it's going all the way up to 53,000. The scale's just what it's going to count by. So it's your X max. Okay, you switched them. This is your X. Your 9,000 should go with your Y.
Oh.
You see what I mean? So your X max, I put it at, say, 100. Now, you don't want it counting by ones on your X scale. I count by 10s or 20. I mean, it doesn't matter. You're just trying to reduce the
Is this
number.
one by one?
So, because that's going to 9,000, you don't want that to count by 18s.
So I do 1,000.
Yeah,
What are your numbers?
and then just hit graph.
How do you do the math?
There you go. And now you can see that
How do you do that?
second count. And you're looking for the max. So you're using this as a guide. Why is it so? Are you zoomed in? Oh, okay. Alright, so you gotta know your X and your Y axis. So this is your Y axis.
Goodness.
This is like Vegas. So,
So.
oh, okay. Oh, did you already see the graph? Oh, okay, max. This is max. And it's gonna say, now put me to the left of it, put me to the right of it, and then it's gonna say, give me a guess. So the maximum area, that means the Y value. So what was the maximum
It's
Y
going so
value?
slow.
Okay,
That's not it.
is area is in square feet, and the smaller sides, which means what is the value of X, would be
I've been
40.
pressing it forever.
Yeah, but now that would be not, that's just the measure of the side, so that's standard feet.
Oh, okay. There's no way.
Did you,
Oh, wait, oh.
you typed, okay. I think you typed.
I don't know, Sean doesn't have.
Okay, so I can't wait to go with that one.
Hey, is Gracie not here today?
No.
What's her surname? Is she his name? Probably okay or probably bad? Domain,
She didn't open her mouth. I know, she didn't know what she said in her mouth. They're like,
So it wasn't, was it a separation?
yeah, she left school.
Okay, this all good. Lucy said you were about four. What you got? Okay.
Okay. Yeah, I was wondering what is annual, and you did a completely different one.
So the max area. Oh! I thought it said the max area of. It's saying, tell me what the large side is and tell me what the small side is. It just wants you to give the dimensions.
Wait, so how do you?
Well, you still need the max. You still need to find the max because that gives you the x coordinate, which is the short side. Then you're going to plug it into your expression for L to get the lengths.
Wait, so you plug the X into both X's?
So
my max is 80, so that's my y.
No, that shouldn't be X. Your max is 80?
My max is 85.
Yeah. Is that the y coordinate?
No, that's my x coordinate.
That's not your max then. Your max, remember, is the y coordinate.
So why would mine be
Hey,
2,500?
That's your area. That's the area.
What?
Remember, your max
Do y'all have the same
area.
numbers?
Hold on. No, y'all don't give up. Let me copy. Hold on a second. There's a lot of stress. Yeah. C is asking for you to simply give the dimensions that would yield the max area, which means state the the length and the width. They want to know what's the length and the width. You have to find the max looking at the graph. They give it to you right here, but I like to go to my calculator just to be sure of myself. So coming down, that would be between 20 and 25, that would be what? From 20 and 20, or 30 would be, so that means x is 25, that was the x-axis, right? So if x is 25, in my problem, the length would be, now I don't know if I came up with the exact same, I'll have to copy the whole new question, because this was from yesterday and this was from today when I hit preview, and I think it changed the numbers. So pretend like this answer is in the context of that. This is 25, so then the length, you would plug it back in to get your length, and then you would have length. And this is what it's asking for. Tell me the long side. The larger side, what is it? It's so many feet. Now tell me the smaller side, which is your width. In my case, it would be 25 feet.
Wait. So you plug it in for X up there, and that gives you the
Plug
larger.
it in for X to give you the length.
And that's the larger.
It's not feet squared. Feet squared is when they're asking you to discuss the area. If you were to say the area is 2,500, you would say feet squared. If you're just talking about, hey, I'm laying a ruler down and I'm measuring this out, then it's just plain old feet. What?
It's saying it's wrong. So then the smaller side is just
The smaller side is your width.
The side is our y max, basically.
No, not Y max.
It's the same. When you got 80, plug it in for x. Yeah, and I still got the same one. I got it wrong. 2, 5, 6.
See, I can't do it otherwise.
Yeah, right. Like, what did you do? Because I was wrong. Are you sure? So, wait. No.
See, mine changed numbers. That's what I was afraid of. Mine changed numbers when I hit preview for the new one.
Oh, okay.
So, my larger side, there is 200 minus 400.
We came up with the x on the side. I read the chapter.
Down.
We got the last 3 chapters. Like, all of us should finish up tomorrow. We should finish up. It's like, what else do you think I'm doing? There's such a thing as today. We're being so
This Holcombe.
Why?
So I'm not gonna.
Put it in
It all in the flex.
Yeah, I put it in
Huh?
flex. See, I told you, so I did get it right. Put it in there.
Do tomorrow.
I
I won't be here. I'm just need help today.
Oh, because like, it's hot. I tried it in the calculator and it made me like 0 cents. So I was like, you know what? I'll just
Well.
put it in between,
It's not doing it tomorrow.
which
I
is
know,
what you
but
would
I'm
do
saying
anyway.
it's
And then multiply.
But it's tomorrow. You'll be, just come in here in the morning at 9 o'clock.
Not with this blade.
Well, remember the bell rings, they still have not sent an email out, but I imagine the bell's gonna ring at 9:18 tomorrow.
Yeah, I'm gonna sleep
Yeah. Did you get it?
No, it's only wrong.
Is aerobic exercise the one that's like jogging?
Oh, yeah, the Sarah.
Yeah,
It's the ones 4X. So your X coordinate
Aerobics, weightlifting.
sure is
Aerobic is
20 by 17. Okay. And then now, and you can check that by plugging in 85.
What did you do?
Is yours in feet or yards? No, it's in feet. Okay. The area is maximum, which means your max area will occur when your length is 340 and your width is 85. Here's how you check it. Do 340 times 85 and see if you get that max area. Did you get 28,900? Then it's right. Yeah. So there's a trick here, right there in the middle. Yeah, so you're gonna do it, and it's domain, which means you use it.
Okay,
Yes.
now check it on times
Valerie, and you grab earlier.
and see if it comes out to the max that you plugged in earlier. Your small
At this point, you're gonna wanna
what you
put
got
that,
from what you
you're gonna close the graph. Or you could, you could sit here with, I was gonna say, you're gonna wanna put it in your calculator and you're gonna wanna use the, in order to state the increasing, decreasing constant, you need to know where your max limits are. So you're gonna have to go through your calculator, this is where you want those straight. And you're gonna find the max and the min.
Yeah.
And then the max and the min, and get those X coordinates, because you're reading the X axis.
It's probably
Okay.
your
What number is that? 5. So it's like,
Oh my gosh. Well, that's negative. Oh. Yeah.
it's like this one, right
Are you
here.
kidding me?
When we graph this one in the calculator,
Oh, yeah.
so,
Oh, yeah.
Okay, I thought analytics was all of your
I don't know
books.
what that graph was like, but with yours, okay, so with yours, I think yours does this.
It's
You've gotta find the min, the max, the min. And you need to know what those X coordinates are. You need to know the X coordinates, because you need to know right here, like what's, in order to do the increasing, decreasing. So once you know the X coordinates, for instance, like right here, this would be decreasing from negative infinity to this X. That makes sense?
Oh, wait. Okay, so mine has numbers.
You want to type it in the calculator.
Mine has negative 1. Wait, no. See, like mine has numbers on
Oh, well then they're giving it to you there. You just use those X coordinates. So this would be, no, just write your intervals. Oh, this is relative max and mins. Yeah.
Like, but this is the top.
Is that all I do that?
No, he's doing increasing and decreasing. You're doing max and min. So that would be, well, that, yeah, right here, that's what you're doing. What I was talking to him about was increasing and decreasing.
So then how do I just plug it in?
No, you don't have to plug it in. They give it to you. You just have to be able to look at that and say, oh, that's a max. At the y value, of the y value at the x coordinate is what they want you to type in.
Okay, so the y is gonna be the relative
Remember,
max value.
The y value is what you type first.
Yeah.
Okay. Go, oh wait, not that one. Go to this slide. Did you find your AirPod?
I don't know if it's even in there. That sounds like it should be.
Okay, let's look at those now.
Now you write your intervals. So you gotta look at the graph and know when it's decreasing. What's it doing here?
Well, it's wanting to increase right now.
So then that means they want you to focus on
What?
that part and that part.
What do you do with those? Just like calculate.
No, you're writing the interval. You're showing it's exactly like this. You're looking at the graph and deciding what x coordinates it's running up, and you write the interval. It's just, they're ugly decimals. That's the only difference. These are nice, pretty numbers. That graph has ugly decimals, and you had to let the calculator find it. But it's the same thing. If this had been like -3 and this was 0 and this was +3, if it had been pretty, the increasing would be -3 to 0 and 3 to infinity.
That's makes sense. Yes.
How is the back? Shoot.
The point of that problem is, can you still state increasing, decreasing, and constant with decimals?
Yes, that was something.
Look at this. Look at this one right here, talking about a doctor's fee. This is where piecewise functions are used in real world situations. For instance, if you go to visit a doctor and you're there for less than, remember these are the rules, if you're there for less than 6 hours, they're only going to charge you, what? $50. I don't like how this is written. This would say if t is greater than 6 and at the same time less than or equal to 15. Okay, so if you're there between 6 and 15 hours, I think it's unlocked. I unlocked it because I knew you were coming back. But if you'll punch it in and lock it. So if you're there beyond 6 hours up to 15 hours, he's going to charge you $80. And then if you're there, if you take up more than 15 hours at this time, he's going to charge you $80, right? And then $5, the way to read this is for every hour after 15 hours has already passed. Because this is saying after 15 hours has passed. So let's say you were there for 16 hours. You only got one additional hour. So 5 times 1 is $5, and then so you would end up paying $85. So if you're there for 20 minutes, how much would you pay? I'm sorry, not 20, what's it say? 12. If you're there for 12 minutes, was I saying hours? Y'all are probably wondering what I'm talking about. Let me write this. Minutes. Makes a lot more sense. If you were there for 12 minutes, you would fall into which rule? Yeah, rule 2, and it would be $80. If you were there for 20 minutes, what rule would you fall in? Rule 3. So right here, you would plug 20 in. 20 minus 5, or 15 is 5. 5 times 5 is 25 plus 80. I'm going to write it. You can, but it's just easier to subtract it first. Yeah. What did we say? 80 plus 25 is 105. Okay, graphing piecewise functions. You've got to get comfortable with being able to graph by hand. Good news is, your test is on my math lab, right? So it's in the computer, which means it's multiple choice. I don't recall the widget letting you graph like this, the graph itself in pieces. Now, I do remember one problem where like you type the equation and then you just enter the rule restriction and it graphs it for you. I don't remember when that was, if that was Trig or this one. But let me show you how to do it by hand, and then I think on my math lab it's going to give you the multiple choice. How many pieces are in this function? 2. Let's take some notes. I want you to use T-charts to help you graph piecewise functions. Remember, this is your rules column, which is where you go to first, because this is where you get to see what X values are allowed. We have 2 pieces, so I'm going to make 2 T-charts. Make your T-charts, I don't know if you want to wait until I've written a few things. Make your T-charts big. There's a reason for this. Your T-chart is going to consist of, I'm changing colors because I want you to know this is the way you set it up. Your rules go first, then your equation goes second. It's backwards to what you're used to. You do need to recall that in a T-chart, the first column is X, the second column is Y. Okay, well in a piecewise function, what column refers to X? The rules, which is why it needs to go first. And from the rules is where we generate the Y values. Okay, so looking at this, my first one, and it helps also if you write these in order. My first rule is X is less than 3. And the equation it goes to is 1/3 X plus 3. My second rule is X is greater than or equal to 3, and its equation is negative X. Now, make notes. Use the rules to generate, which means to make a list, to generate your X values. Y'all remember in math always hearing, you can pick any number you want and you can plug it in and you get an answer and then you graph it, right? Can't do that here because there's rules. Makes sense. Now it should be coming together. Like, can't pick any number because there's a rule. This says, hey, pick any number, what? Less than 3. So here's how with all these piecewise functions that you're going to do this. Use the rule, generate your x values. Always start with critical numbers. The critical numbers are the ones listed in the rules. Even if it has an open circle, start there. Because now you know where to put your open circle on your graph. So you're going to start at 3, and I'm going to come over here next to it and put a big open circle to remind me, don't fill it in, right? And now it says count what direction? To the left, right? I did it again. To the left, right? To the left, correct? So count less than 3. Now, don't write the 2, 1 yet. Hold on, just watch. If you already wrote it, it's fine, you can erase it. So now we're going to just plug it in. This doesn't happen often. It happens in the very first example, which is frustrating. We're going to plug it in. If I plug 3 in right here, you would go to your calculator, or you can do it in your head. 1/3 of 3 is 1, plus 3 is 4. 1/3 of 3, right? If it helps, this little x right here, if you think of it as up here, it may help as well, because basically you're dividing by 3. Now, when I plug 2 in, I'm going to get a what? I'm going to get 2/3. Do I want to graph 2/3? No. I don't want to graph 2/3. So here's something I want you to write on your paper. Let me change colors. Blue. I'm going to draw an arrow to this equation. Pick numbers divisible by 3. Why did I say 3? Because it's 1/3. You do get to pick any number you want as long as it falls within the rules. So we get to pick any number less than 3. Well, let's pick numbers that are nicely divisible by 3. So that when I go to graph, I'm not graphing 2/3 on this graph. So 2 is not helpful here. So I'm going to draw an X. No. I'm going to slash it out to let you know that it does fit in the rule, but I don't want to graph that. I'm going to pick 0 instead. I always like 0. 0 makes things easier. So 1/3 times 0 is 0, and plus 3 is 3. Do I want to use 1? No, that's not going to help me, because then I'm going to have 3 1/3. I don't want to graph that. Now remember where we were counting. We're counting less than, so we hit 0. Let's do, you could do -6. I was going to do -3. But yeah, -6 works. So 1/3 of -6 would be -2 plus 3 is 1. Those are a lot easier to graph. Now this one, none of that nonsense going on. That's only when you have a fraction next to x that you gotta choose wisely. Okay, here, start with the critical point. Make an indication next to it what type of circle. Then count the direction it tells you. I usually do 2 or 3 numbers. Now plug it in. Well, if I plug it into that, it just negates them, right? Now we've got to somehow take it from the T-charts and put it on the graph. Let me show you a technique that I use to do this. I take a highlighter and I highlight a vertical line at the critical points. What was the only critical number here in this problem? 3. So I find 3 on my x-axis, right there, and I drop a highlight. Ooh, too much. I drop a highlighted vertical line And now I can compartmentalize, remember, lunch tray, man's brain. I can compartmentalize, I got my left side of this piecewise function, I've got my right side of it. This went to the left of 3, so that's going in this big section. This went to the right of 3, so that crap's going over here. You see? It's almost like organizing your thoughts. Now we put it on there. Now you need to be intuitive enough to know what you're graphing. This was what? What type of function? Read the degree. This is x to the first power. That means it's linear, right? So when you go to graph, don't sit there and draw that. It's not a quadratic. So make sure you're paying attention to, and it would help maybe if you come over here and just say to yourself, okay, this is linear, this is also linear, so I just have 2 lines on here. All right, let's graph it. We got, the critical point is 3, 4, what type of circle? Open. So right 3, up 4, open. Then 0, 3. Then -6, 1. And we said it's linear, so I am just drawing a line, but I'm intuitive enough to not do this. Why can I not do that? There you go. That's why the highlight helps. It's literally lunch tray plate telling you, hey, you're in the wrong compartment. It'd be like a man looking at you and saying, that was years ago, let it go. And you say, nope, that's not how my brain works. It's a spaghetti brain. Okay, now let's do the next one. Right 3, down 3. What type of circle? Closed. Right 4, down 4. Right 5, down 5. Once again, you cannot do this because now it's not a function. You are simply going that way with it. Now, I have seen people get confused as to when to put an open circle or a closed circle. It only occurs, open circles only occur in the critical numbers. These numbers that you picked here and here, those are always closed because that was in the rules. It's the numbers at the critical points that you have to be careful. You have to find all the maximums. That's what Connor was at. You've got to go to your calculator for the second calc and get all your mins. Well, they're just saying that's how I can see it.
We don't need that till this part. After lunch.
Now you try to do something find your mins.
I'm not even gonna be hungry.
Remember me saying, these are going to be ugly decimals. You're only interested in the export it. You're talking about interest increase in interest. But it's just looking to see, can you still stay in interval? That's saying of the, which one did you do first? Min or max? Right, this right here, it's saying that it's at x equals 69. They're like barely, Yeah.
For your like sub notes tomorrow, and you put like do your homework, if done, take notes.
Well, I did put the only thing they need to work on is the synthetic exposure. Me? Open it back up.
One color.
So it's decreasing flow and it's decreasing. Now remember, decreasing and increasing red light book. Well, it's got two, but it's like you said in your mother's look at it.
Now that I think about it, I get more migraine. I and I almost brought it to school, so I was like,
And remember,
they're kind of two different grades.
I mean, you're gonna want to get another paper, write down those max and min values.
Neon green.
No, that's still over your pressure. That's like right here. Condensed.